Cool. Should I
All
get
right,
started?
Yeah, go for it.
All
Thanks.
right. Let me share my screen here. Also, warning, I realized there's a bunch of animation. Oh, wait, hold on. I can't screen share, Sam.
All right, so I just made you a co-host. Try now.
Okay, one sec. Share screen. There we go.
Cool, I can see it.
Loading. Okay, cool. Can everyone see this?
Yep, looks good.
Yep. Okay, great. So yeah, I'm excited to be here, everyone. I was connected with Brandon a few weeks ago, and he thought it'd be a good idea for this group to chat through a little bit about what Apache Airflow is. I'm sure a bunch of you folks have heard of it. It sounds like some folks are actually running it right now. So this talk will be a pretty high-level introduction to what the project is, what types of things you can do with it, a high level of the core components that make up this thing, and then of course what Astronomer does specifically. So my name is Paola, and I'm a product manager. Oh, hold on. Here we go. I'm a product manager at Astronomer. So I've been working here for a little over 3 years. So I'm a founding team member as well. Originally from Mexico City in New York, but I moved to Cincinnati, Ohio to work at Astronomer. Although now we are totally globally distributed. And I never know what fun fact to throw in here for these things, but for anyone curious, I'm currently reading this book called Say Nothing by Patrick Keefe about the troubles in Northern Ireland. So would recommend, but totally unrelated to this topic. So, and then on Astronomer, so Astronomer is a commercial developer of Apache Airflow. So for folks who are familiar with Confluent or Databricks, or sort of what Confluent is to Kafka, Databricks is to Spark, and we are to Airflow. So we're a startup. I live in Cincinnati, like I said, but we're totally globally distributed. So we have folks in San Francisco, London, Warsaw. We have a coworker of mine lives in Mauritius, the island off of Southeastern Africa, and we are hiring. So for anyone interested, happy to chat with you all about that. And we're a little over 105 people. So when I first started, we were 6, and now we're certainly growing pretty rapidly. So it's been an exciting experience, and excited to chat with you guys through what we've actually built out of this thing. And our mission is to unlock the value of data in motion with Apache Airflow. Cool. So in terms of what we'll go over today, I figured this would be a good place to start. So I'll go over what is Airflow, a little bit about the project history and core components, like I said. 2, what is an example of a DAG, which is Airflow jargon for pipeline, data pipeline. 3, how is Airflow 2.0 a game changer? So for folks who are familiar with Airflow, we just came out with a pretty big release at the end of December. And I'm going to talk through pretty high level what some of those features do for the project. And then 4, how do you actually deploy this thing? Like, cool, this is a project, but how do people run it in production and at scale? And then 5, related to that, what is Astronomer and what value does our product actually bring to this experience? And then to top it off, I'll talk a little bit about, if anyone is interested in getting started and hasn't, some resources to help you do so. Also, totally feel free to interrupt me with questions. Happy to make this more conversational if people want. So feel free to chat me. I might not actually see the chat, but Sam or Brandon, if there's questions, just let me know and I'm happy to stop.
I'll let you know. Thanks.
Cool. All right. So what is Apache Airflow? So put simply, Apache Airflow is an open source tool built for developers to programmatically author, schedule, and monitor data pipelines in Python. So all that to say, if you have data from a bunch of sources, you need to do some stuff with it in between and throw it into some sort of destination, but you want to have full flexibility in that code. Airflow gets that job done and does so in a really excellent way. So for some project history, Airflow was built by a data engineer at Airbnb in 2014. Name is Maxime Bushman. He actually has since created another Apache level project, Superset, and created a company out of that named Preset. So it's a data visualization tool for those of you interested. And he created this, like I said, in Airbnb in the wake of a shift away from drag and drop ETL tools and a push towards code as abstraction and developer first, code as abstraction and developer first tooling. So the project was pretty successful from the start, and eventually graduated to a top level Apache Software Foundation project in 2016, which is cool and sort of a nice stamp of validation for the need that this thing is trying to solve. And then by 2017, it's been adopted by over 1 million data engineers around the world. So super global presence here, as a lot of technology obviously is. And it's deployed by thousands of companies as sort of an unbiased data control plane that for a lot of folks translates business rules to power their data processing fabric. And it's a vibrant community. It's one of the things that I'd say folks who do use Airflow love about it. There's a lot of people involved. And we have over 1,500 contributors to the project. And you can see I had literally pasted this from our GitHub repo, or the Airflow GitHub repo. So development has certainly picked up over the past couple of years. You'll see a spike there when that 2.0 release that I mentioned came out. And it certainly won't stop here. So that's some general history for you guys. And then throw in here some logos. These are some companies that use Airflow. Certainly spans across industries, sizes, and specialties, teams. Some of these are Astronomer customers, some of them are not. But just to give you guys a sense of how sort of ubiquitous this tool is. So why do all these people use it? Why has it been so successful? And what empowers data engineers to use this to solve their problems? So there's a couple benefits to Airflow. First, it's dynamic. So everything in Airflow is written in Python. So anything you can do in Python, you can do in Airflow, which makes it very powerful. Two, it's extensible. So Airflow has many plugins available out of the box. And if it doesn't have something you need, you can create it your own. And that also comes in with the power of the community, right? And then finally, it's scalable. So depending on your configuration and choice of executor, which is sort of Airflow jargon for the thing that executes things, Airflow can execute many tasks and many DAGs pipelines simultaneously. So Astronomer makes that piece even easier. And we have customers running over 50 Airflow environments, dozens of data engineers, developers, data scientists, running over 800,000 tasks a month. So you can start small, but also you can get pretty big with this thing. In terms of, and again, stop me for any questions, but I'll just keep going otherwise. So in terms of core components, what are the things that actually make up Airflow? How does this thing work? So the first main component that I'll mention here is the Airflow web server. So this on the back end is a Flask server that actually serves the Airflow UI, which I'll show a screenshot of in a second. The second component here is the scheduler. So this is sort of known as the powerhouse of Airflow. It's responsible for scheduling jobs. And especially after our latest major release, the scheduler, is seen as the primary engine of Airflow, and you can actually run multiple schedulers to do more tasks in parallel and ensure high availability and things like that. The metadata database is a central isolated database where all metadata is stored. History of your tasks, when they should be run, and this is sort of central to the communication of all of these other components. On Astronomer, we run this in Postgres database, but you can also set up a MySQL database as well. And then a few other components that are not as critical as these three, but certainly make Airflow easier to run. The first is the Airflow executor, which works closely with the scheduler to figure out what resources will actually execute a task via worker, process, or otherwise as they're queued. And there's 3 to 4 different types of executors here that you can use depending on your use case, depending on your infrastructure, depending on your budget. And users can totally pick from all of those, again, depending on what you're looking for. And then the worker is actually processing the task. So workers are the ones that do the work themselves, as told by the executor and as sort of triggered by the scheduler. Cool. So yeah, I think that is about it for this. And then I have this, I stole a graphic that sort of puts these pieces together for folks who are more visual. So you can see all of these components talk to the metadata database here. You can have multiple workers here doing jobs at the same time, and then an executor and scheduler that sort of orchestrate these things. So the main, in terms of what a DAG is, so I mentioned DAG is sort of the main unit in Airflow, and it is, again, Airflow jargon for a data pipeline. And a DAG stands for directed acyclic graph, and that is made up of tasks. So the most important rule for a DAG is that tasks flow in one direction and one direction only, with no loops, hence directed and acyclic. So the first graphic here is valid, where T2 and T3 depend on T1 and T4 depends on T2. And the second graphic here is invalid, right? Because T1 depends on T4 and T4 depends on T1, and that could create an infinite loop, which is evidently not allowed. So this is simple, but really, as you'll see in a screenshot later, these DAGs can get to hundreds and hundreds of tasks and dependencies, depending on how far you want to go with it. And this is what, I mean, a smaller scale, but this is a screenshot of the Airflow UI and the graph view of these tasks. So each of these boxes are a task. The sort of color around them dictates the status of that task. In this case, all of these dark green boxes means that the task is run. And then these might have been skipped, or there's some other logic, skipped, queued, running, or whatever logic the data engineer decides to set here. And at a higher level, this is the sort of Airflow UI home, where you have a list of all of your DAGs. So if you're working on a team, you can have multiple pipelines here. You can set the owner, you can see the schedule at which these pipelines are set. These are set in cron. You can see last run, you can see, and then a bunch of links to other resources for that pipeline in particular. So another important concept here is the Airflow operator. So operators are the building blocks of DAGs. They're a wrapper around each task that defines how it's going to be run. So in the example on the last slide, each of those T1, T2, et cetera tasks would have an operator defined in that DAG. And there are a few different types of operators. So action operators execute a function. So like Python operator, bash operator, and these just say execute X Python function or run this bash script, for example. Transfer operators move data from a source to a destination. So, move X tables from Snowflake to S3. And then a sensor operator waits for something to happen in order to do some task. So for example, run this task when a new Jira ticket with X tag gets created. So these are super powerful tools for Airflow and sort of let you plug and play a lot of different components that either you've written yourself, or the really cool part is that other folks in the community have often written these, especially for more popular tools, and you can just take those, pull them into your pipeline and run them really, really easily. So yep, this sort of shows the hierarchy between a DAG, operator, and task that I just mentioned. So a task to emphasize is an instance of an operator. So you can think of it as the thing that's actually doing work within your pipeline, running a function, transferring data, et cetera. And a task instance, one level deeper, represents a specific run of a task. So for a DAG, at one point in time. So yesterday at 2 p.m. would be a task instance if that thing started and finished. So if you pull all these together, a DAG is your data pipeline. Within a DAG that you have tasks, there could be one or many dependencies set within that pipeline, and you can define them in whatever way you need to. And then, so sort of like I mentioned before, because there's so many community created operators and modules for Airflow, you can really plug and play a lot of existing components, and it is more than a community centric effort. And I think this comes to show how powerful Airflow and the open source community really is. So these are some of the built-in connectors for commonly used data services that people have contributed. So you've got Oracle, Kafka, Slack, Databricks, Talon, Snowflake, TensorFlow, Tableau. So a lot of these things, if you use these tools and you want to get started with Airflow today, you can plug and play with a lot of these existing components. And this is a screenshot of the Astronomer registry, which we actually recently released, unrelated to our product offerings. It's just on our website. But it actually pulls the source code for all of the existing sort of providers and operators and makes it into sort of a marketplace where you can look at things that popular tools have validated. So we're creating partnerships with Fivetrain, for example, are building the best way to use Fivetrain in Airflow. We upload an example pipeline here. We tell you what sort of connections to that tool you need to make. And it's a really cool way to very easily connect to the tools that you need to. And if you're a contributor, a way to contribute to the community and customize your own code in the way that fits your use case. So last on the Airflow piece, I wanted to emphasize what Airflow is not, because often that's also helpful. So Airflow is not a data streaming solution. It is not a processing framework like Spark. It is an orchestrator. And with the Spark example, it can orchestrate Spark jobs. So if you have massive data sets that you're doing transformations on, for example, you would want to keep those transformations in a framework like Spark and just use Airflow to orchestrate those jobs and dependencies with other things that are related to that process. Cool. So I think no questions yet, so I'll just keep going. So part 2 here, what would a sample DAG look like? And this is not in the Airflow app, but just a general sort of example of what a user might do here. And so you might have 2 or more data sources here, website, some sort of payment data with credit card information, and you're pulling from those sources, you're scraping from your website, you're pulling some sort of transactional file, you're using operators to do this. You upload those files into Redshift, and you pull those from Redshift, you Spark job to do some analysis on that, and then generate a prediction. So there are obviously a million use cases, but this is sort of a basic one that we see customers do when they're getting started, and depending on the tools they're using and their use case. So third part here is, how is Airflow 2.0 a game changer? So Airflow 2.0, like I mentioned, was released in December of 2020. So just this past year, we had over 100 contributors to that release. We're now on 2.02. So for those of you who like to wait for a couple of patches, bug fixes have definitely been made since then. And we did just release an Airflow 2.02. And this is a really significant moment for the Airflow community. We actually had been on sort of a 1.10 series for a really long time, partly because we were still supporting Python 2.7, and that was forcing us to build every single thing in Airflow as compatible with Python 2 and Python 3, which made it difficult. Development was slower. But with Airflow 2.0, we only support Python 3, and that's made it way, way easier and faster for us to develop. So PRs are getting merged faster. We're getting more contributors. I mean, there's certainly a sense of momentum. And I think some really big features that have been on the docket for a few months that the Airflow community was excited about, but hadn't seen. So I emphasize here the sort of tighter release cycle, faster development, which just makes for a stronger and more energetic community. Specifically, Airflow 2.0 also came out with a full REST API. We actually did not have that before. And it separated out providers from the core Airflow base. So all these operators and modules that I've been talking about that help you connect with other tools, they were actually built and versioned with Airflow. But because we realized that part is so important to the community and to development, that we actually removed it from the code base and are releasing and versioning those providers separately, which empowers service providers like Fivetrain, Databricks, et cetera, to develop on those without having to deal with the baggage of contributing to Airflow and all that process is. And users can get those releases quicker without having to wait for the next Airflow version with that sort of new piece of code. So really excited about that in terms of the community aspect as well. A bunch of UI UX improvements, the Airflow UI that I just showed you, that's brand new. And then from a performance standpoint, a new highly available scheduler was released. So as a user, you can now run more than one scheduler, which is great for high availability. If one scheduler goes down, they're both working at the same time. One can adopt your tasks. So just overall much faster performance. So tasks just get executed faster. And it's great from a reliability standpoint. So a bunch of other things, but these are sort of the features I'd highlight here that make us really excited about 2.0. So yeah, this is a slide about the scheduler, so I sort of just covered it, but like I said, highly available, significantly faster, and infinitely scalable, as they say. So this is just a little visual that encapsulates what I just described. So something we're definitely really, really excited about.
Hey, Paola, I have a question.
Yep.
This is David.
Yeah.
So I think Brandon actually spoke on this like at one of our first meetups a while ago, but I know he touched on this, and maybe you can expand on this a little bit, like the difference between orchestrating and actually like moving data. I kind of see those as two separate things, like, you know, orchestrating a job versus like going into a database and getting data and, you know, extracting it and putting it into another format or different, you know, file.
Mm-hmm.
Like, can you, like, is there a distinction? Do you guys make a distinction there, and kind of, like, do you have any thoughts about that distinction?
Yeah. I mean, it's definitely sort of a gray line, especially because, you know, as I said, if our scheduler is faster and things are getting executed faster, then you'd sort of think, well, like, let me just do all this stuff in Airflow. But I think Airflow, and you can, but I think Airflow's strength is more in the pure scheduling, like deciding between dependencies, the monitoring that comes with that, the UI and CLI that come with that functionality. And I think you can do that stuff in Airflow, but I think ultimately you'll hit limitations with like the database, for example, and with general like parallelism settings that aren't built for that specifically. So it's something that I would say we're, you know, forming stronger partnerships with tools that help people do that. And I think as a best practice, we generally say, keep Airflow as your orchestrator and do the actual data processing in some other tool. Now, people do it on Airflow, so it's not, you know, an absolute faux pas, but I think if you want to maximize for Airflow's strengths, you'd sort of end up adopting that model. But like I said, Airflow is sort of moving in a direction where it can handle more in general. And so we are seeing like quicker turnaround or like more tasks that take less time and that happen more close to real time and things like that. But if you need something to hit the database every single second, Airflow is probably not the best place to do that. If other folks have thoughts on that too, though, happy to hear it. I'd say that's sort of our stance, at least right now.
That's helpful. Actually, one more question. When you talk about the executors, like, do you talk about where that's actually running? Like in other words, is there distributed processing that's going on, you know, in terms of the actual running of the jobs, or is it, where does that actually run, I guess, is kind of what I'm trying to understand.
Yeah, great question. So there's a few different executors. I'd say the main ones that relate to your question are, well, there's really three main ones right now. Local executor, which basically has like one worker and it, you know, it just literally uses your laptop or whatever resources you give it, but there's no parallelism. Well, two tasks can run at the same time, but it's just one thing. And then you have your Celery executor, which uses like Redis or RabbitMQ as like a queue broker. So you have different like queues of tasks that you need to get done. You have multiple workers, and those workers are talking to the database and executing tasks in sort of different streams. So for a scaled out use case, that's definitely what people use the most for production. And then you have the Kubernetes executor, which does require Kubernetes infrastructure. So you obviously need to run Airflow in a Kubernetes cluster to take advantage of this. But that one actually dynamically creates Kubernetes pods to run those tasks. And then those pods run like disappear or spin down when the task is finished executing. So for folks who want to optimize a little bit more for cost, that is better. Sort of depends still on your use case. For example, if you have tasks that a lot of tasks that need to run in parallel and have quick turnaround, then the cube executor actually is a little bit slower because a pod needs to spin up, spin down, spin up, spin down. But it's a little bit better cost wise. For the celery executor, you provision those workers like once and they're fixed. So you kind of have to pay for the resources that you give it, even if they're not doing the work. So those three, I'd say, are the sort of three different general executor categories and how they actually work. Does that
Thank
answer
you.
your question?
Yeah.
Cool. Good question, though. Devil's in the details. Anyone else have questions while we're here?
It looks like we have one more question in the chat. I can read it out if you can't see the chat.
Oh, I got it. UI has definitely been a bottleneck when creating a lot of DAGs and sub DAGs concurrently. This is from Alex. Yeah, Alex, are you what version of Airflow are you using? Or are you just referring to pre 2.0?
It's pre 2.0, yes. And what we do, we create a bunch of DAGs via REST API, and it seems like it's just basically not responding in a timely fashion when we push the new DAGs. It looks like this the scheduler that creates DAGs doesn't pick them up on time. It doesn't report back the DAG has been created. So we've seen a delay of like up to 8 minutes to see the DAG being created. Now, these are fairly complicated DAGs. They have sub DAGs. So it's not a simple one DAG that has just a bunch of tasks or operators defined.
Mm-hmm. Yeah, that is, I'd say that especially in the later Airflow 110 releases, the web server, which is the component that powers the Airflow UI, was actually pretty greedy in terms of resources. So we had to advise our customers to beef up the CPU and memory that they allocated to the web server to sort of handle that. I'd say something that we're working on is the deploy process and how that affects like web server downtime. So if you deployed set of DAGs, historically, you might see the Airflow UI, depending on how you deploy, you might see the Airflow UI go down while like a Docker image gets rebuilt, and that Docker image with your dependencies and your DAG files get pushed out to the pods that are actually running Airflow. So we're trying to make that a smoother process that doesn't require, your Airflow UI to go down. But in general, there's probably something to look into to optimize your web server or optimize parallelism and whatnot between your DAGs. So if that's something that you're still seeing, definitely happy to follow up on that and see how we might be able to help you optimize that.
Thank you.
Yeah. Question from Brandon. What type of guarantees are there in the scheduler? If I schedule a job at 9 a.m., how close to 9 a.m. is the scheduler guaranteed to execute that job? That's a great question. So for one, the Airflow scheduling is a little bit counterintuitive and wonky. So if you schedule an hourly job and you say that it should start at 9 a.m., it actually will start at 10 a.m. because it thinks that it needs the whole hour of data beforehand to start doing its job. But that aside, I'd say it's generally, typically accurate and depends on on time, depending on as long as the dependencies before that job are met, then there's no reason that task shouldn't run unless something's wrong with your database. But it should at least start executing at that time. Again, as long as dependencies are met and your components have resources to do their jobs. But there's no like innate delay because of Airflow, more generally, if that makes sense. Brendan, does that answer your question?
Yeah, that makes sense. I didn't know if there was like guarantees when a job would execute. If you have hundreds of jobs, I don't know if this scheduler kind of works like the Kubernetes scheduler. Does it kind of have a cycle, where it executes?
Yeah, it does. So I'd say as long as you set that job at the time that you want it to, and again, the dependencies are met, then there's no way it shouldn't. something that the Airflow 2.0 schedule addressed was like a lag between, like if there's a ton of tasks to schedule, it might take a while to do that. So it doesn't necessarily mean that your job won't start because it's not executing yet. It's just like telling it when to start. But that's something that the 2.0 scheduler really sort of took care of, and we're seeing pretty fast performance there. So Brandon, I'd say honestly, like that depends on your the workers that you have that are doing their jobs. If like your workers get backlogged because they have hundreds of tasks, like you will see a slowdown, but assuming there's enough resources, there's no like reason it shouldn't work. Yeah. And then I see a question from Leo about Argo. So great question. I actually am not super educated on Argo. I know that our team has talked about it, but I would actually have to follow up on that. Does anyone here use Argo? Who can speak to it?
Besides Argo relying on Kubernetes,
Yeah, that's
it's pretty much the same.
Yeah. Okay. Well, although I don't think we have any sort of docs or at least astronomer wise on that, but I can follow up. Cool. All right, I'll keep going. So part 4, how do people deploy Apache Airflow? So I'd say there's typically a few ways you can do it. And from the Apache project, 2 Airflow artifacts are basically generated, a Python wheel and a Docker image. So with that Python wheel and or Docker image, you can deploy Airflow in a few different ways. One, you can just run the Airflow Docker image with Docker Compose. This is super easy on your machine. You create a project with the files that you need, Docker file, you have the Airflow Docker image in there, your DAG files, and you do Docker Compose up and your project is on and you can access the Airflow UI. You can also pip install Apache Airflow on a virtual machine or multiple machines, depending on how far out you want to scale. Or probably most popularly for folks running in production, you can deploy onto Kubernetes via a Helm chart. So the project has Astronomer contributed an Airflow Helm chart to the community, which is open source and you can use it. And it has a few level or layers of configuration there. Or you can run that Docker image. Astronomer has their own Docker image, which I'll talk about in a little bit, but the project also has an official one that works totally fine and has everything you need in Airflow in it. So with that said, I wanted to chat a little bit about the challenges in actually maintaining an Airflow environment. So authoring DAGs in Python is pretty easy, especially for, you know, as far as data scientists, data engineers, developers in general. Typically something that, yes, there are best practices and plenty of things to learn and do, but at least to get started, it tends to be pretty easy. But actually deploying Airflow in production, maintaining it and running it at scale means you have to do a few different things. Configuring a metadatabase, creating a process for your DAGs to be deployed. Some people use like git sync, or you can decide to build it into a Docker image. There's a few different ways there. You would have to set up CI/CD for multi-person teams, manage user and access controls, configure IAM roles if you're on AWS, GCP, and want to connect some of those resources and permissions. You actually have to manage a Kubernetes cluster if you want to take advantage of Airflow's Kubernetes executor, which I was mentioned earlier, and setting up monitoring and learning. So obviously none of these things are required, but for folks who are really using Airflow at scale and in production, these are things they ultimately end up looking into and end up having to manage if they're running Airflow in-house on their own. So with that, so what's Astronomer and what do we bring to Airflow? And I'm going to try to make the least salesy pitch possible. But Astronomer is basically Airflow as a service. So we provide a Kubernetes-based framework for Airflow that addresses some of those challenges in actually running it. So our goal here is we want data engineers, data scientists to author data pipelines, and we want that to be the only thing they have to worry about. So we provide a hardened Airflow Docker image, which is actually open source, and we backport. We work with the open source community to identify and fix bugs, security issues, and we actually backport them. So those end up being available on Astronomer's Docker image before they're actually released in the open source community. We have an Astronomer UI that lets you do everything from create a deployment with a single click that provisions all the components that you need, allows you to set the resources for each component that you need, and has monitoring, alerting, etc. We have the Astronomer CLI, which is a wrapper on Docker Compose that makes it super, super easy to get started, especially if it's your first time using Airflow and you're just in front of your laptop and want to get it running. Super, super easy. And then we also ship with a Prometheus Grafana monitoring stack for system admin types and a sort of higher platform level view on what's going on with your deployments, which resources are healthy, unhealthy, etc. And then role-based access control. So, you know, we have like admins, editors, viewers, and you can sort of control which level of access you have to which permissions in Airflow and permissions on Astronomer. We also have all system integration. So if you want to integrate with SSO, Okta, Azure AD, etc., all those things are things you can configure with Astronomer pretty easily. And we deploy with cloud native architecture, and we deploy anywhere on Kubernetes. So we do EKS, AKS, GKE, OpenShift, and I think that's it. But yeah, so cloud native. And takes care, I think, of a lot of the challenges that that I mentioned earlier when teams are actually running this thing in production and at scale. So this is a little graphic. So you can see each of these sort of ones with Airflow logo or Airflow deployments, each with its own Airflow UI. Each Airflow deployment is deployed in its like isolated Kubernetes namespace with like its own database that is also isolated. And then you have deployment and platform level monitoring, like I mentioned, our API sort of controlling all of these actions, and then our CLI as well with some input. So in terms of our actual products, we have that sort of hardened Airflow image that I mentioned, open source, and all of our customers use that when they deploy onto Astronomer. We have Astronomer Cloud, which is a managed SaaS, or for folks getting started who don't run Kubernetes in-house, don't really want to deal with that infrastructure layer. We have a pay-as-you-go offering that runs on Kube, a Kube cluster that's hosted, managed by us entirely. You just pay for the CPU and memory for your jobs, and the goal there is to abstract the the everyday data engineer from that infrastructure management layer. For folks who are more security focused, want things run in their own environment, we also have Astronomer Platform, which is self-hosted. So it's literally the same cloud stack deployed in your environment. And if you're a system admin or an architect, you can give your team Airflow as a service. You can be that one that manages it, and you can have dozens of your team members taking advantage of Airflow without having to, again, deal with that infrastructure layer. And then, of course, support services. We have a large team of Airflow experts, a lot of which, spend their days contributing to the open source project, building features, and we're certainly here to help through folks' journey with Airflow. Any questions there? I don't think there's any.
Actually, Paula, hi, this is Roland. I do have a question. I'm trying to understand the operating environment. So let's say I had a Spark cluster, okay, and I have a series of, I have a pipeline I normally run against that cluster. I'm assuming, and again, I'm new at this Airflow, so I'm assuming that what happens is I can build a pipeline or define the pipeline in Airflow. I can schedule when I want it to run. I'm assuming what happens is Airflow kicks that off, submits the job to the Spark cluster, monitors the job, and at some point in time, I could go into Airflow and say, okay, this is when the job kicked off. Here's the logs from the job. Here's what it produced. Is that part of what Airflow does for me?
Yeah, that is exactly what Airflow does. Yeah,
okay.
I'd say the logs. So you'll see Spark logs, not in the Airflow task. So that's something that you'll have to like go to Spark for, but the logs for the task in Airflow and whether or not it ran. And let's say you had some dependency conflict, like you might see an error in the Airflow task, but if there's an error on the Spark side, you'll have to go to the Spark logs for that. But otherwise, everything you said is totally accurate.
What happens?
Yeah.
Okay, okay. And Airflow is running on a separate set of servers, and it's submitting jobs wherever you need to submit the job.
Yep. Yeah. So you connect, like if you want to drop data into a database, like you would create an Airflow connection. Like there obviously has to be a way to connect these systems. So you create a connection to that database, to that tool with some permissions. Or if you want to connect IAM roles, you can do that, for example. And that's all Airflow needs. As long as that connection is successful, that is all Airflow needs to actually kick that off. Make an
Okay.
API call or whatever it is.
Great, thanks.
Yeah.
So one more question on the flow that you mentioned, right? It needs to be unidirectional, as you said earlier.
Mhm.
So let's say I have a tasks and one task fails and I need a logic that needs to go back to previous task and rerun both the tasks. Do we need to code ourselves in our application logic, and Airflow doesn't provide an easy way to create that kind of task dependency?
No, you can. It would like consider it. So in the Airflow world, it wouldn't like go back and rerun a task. It would just do it again. So like you can set that dependency to say, if X or Y thing happens or fails, then do this, but it would still be linear, you know? And that task, let's say it doesn't fail, that task might get skipped, but it's still like a box that you have to pass. And if that dependency like happens, then that task does get executed. So you can rerun tasks. Like if you say, you just manually literally want to have something run again, it would create a new task instance, which is like the little task box, and it would just execute that. But again, like in a linear fashion, like moving to the right. And then on a related note, you can also set backfill. So let's say that today is, April 28th, but you want data from like January 1st of this calendar year to today. You can set there's logic in Airflow where you can set a backfill that pulls data from all of those days to today. So there's a few ways you can sort of do things based on historical outcomes or dates.
Okay, and this is all the workflow design, the UI part you're referring to, not necessarily built into my application code or logic itself, or in my data pipeline, correct?
I'd say this stuff is a little bit of both. You can, in your DAG and like the Python file, you can set like retries, for example, and you define the specific tasks and the dependencies between those tasks. But you can also go into the Airflow UI and like click a button and do like retry or clear task. So a little bit of both. There's a manual sort of escape hatch, but you can also just build that into your code so that you don't have to deal with it.
Okay, thank you.
Mm-hmm.
Wouldn't you be able to handle that by having a dynamic DAG?
Yeah, I think so. I definitely know that we have a bunch of folks who do that and who like create DAGs depending on if some dependencies are met. So yes, you can definitely leverage multiple pipelines there and have some sort of connection between pipelines as well. I think there's another question here. Can operators within DAGs? Yeah. Operators within DAGs can definitely run in parallel. So operators basically like define the tasks, and you can run as many tasks as you want in parallel. Obviously, depending on the resources that you have allocated, but you can do things in parallel as much as you want, as long as you set your dependencies in the way that you want to. But yes, absolutely. That would require the Celery executor. Yeah, for the most part at scale, like most folks who are running a lot of stuff in parallel do run it with Celery or the Kubernetes executor. The local executor can run tasks in parallel, but it's just more constrained resources wise. Like it's the same machine doing those jobs, even if those jobs are happening at the same time, versus different streams of priority and different machines doing that work. Cool. Okay, I'll finish off and then if you have more questions, definitely can answer those. So last part here, what's the best way to get started? So if you're new to Airflow, there's a bunch of resources, a lot out there on the internet. So I didn't include all of them. Obviously, if you just Google get started with Apache Airflow, a bunch of things will come up. But I would say the Astronomer CLI is really great to get started. So if you haven't started it and you don't even necessarily have a DAG written, you don't have to. You can install our Astronomer CLI, which is super easy via Homebrew or curl. You do one command that's like astrodev start. We have a whole directory set up for you with a folder for your DAGs, a folder for your Python packages, a folder for OS level packages. And we basically bundle all of that up into a Docker image, and we push that Docker image out. And you can do that really easily. Again, it's a wrapper around Docker Compose. So for folks familiar, should be straightforward. And you can have, the Airflow UI running on your local machine really, really easily. So 3 Docker containers get generated there. One for the web server for the Airflow UI, one for your scheduler, and one for your metadata database. So you also have local Postgres there. And it's easy to get, at least just get a sense for like, what is Airflow and what does it feel like to deploy? What does a DAG file look like? We have some example DAGs in that directory as well. So I'd say that's a great place to get hands-on started. In terms of like education materials, like I said, there's a ton out there. Mark Lamberti is particularly known for his internet presence on all things Airflow. He's a super great, charismatic guy and really engaging. So his YouTube videos are awesome. Obviously there's Airflow docs, there's the Airflow Slack community, which is huge. There's like thousands of people in there with a lot of different questions and channels for different topics. And then the Astronomer forum is also a great place if you're an Astronomer customer, but also if you're not. And I personally monitor that and answer questions, and as do folks from our support team and the Airflow engineering team and things like that. So I'd say all those are great resources. And then for folks interested, we actually just launched a sort of like certified program. So Mark actually created a test. So if you want to sort of prove to the world that you know Airflow and are good at it, you can take a test and have like a little badge and share that badge with your network. So that's a cool thing that we just added. And obviously unrelated to our product offerings, totally. That's just a community aspect. So yeah, I think those are the best places. But again, there's, depending on your use case and your style of learning, there's a bunch of different avenues you can take. Oh, and before we finish, we do have the open source project is sponsoring an Airflow summit. So ideally an in-person conference, but obviously for this year, it will be remote. It is in July. And everyone's welcome. We'll have a bunch of talks daily from the open source community, committers, and like leadership from the Apache Airflow project, folks from Astronomer, folks from Google, AWS, companies that use Airflow. So will be all ranges of topics, and definitely encourage you guys to go if you want to. So here's the link. And that's all I got.
One quick question. I think I saw a similar question previously about Argo. So besides being open source, how do you differentiate from tools like that, like Azure Data Factory, right? Or Argo, or,
Yeah, it's a good question. I'd say certainly like, a classic answer is the vastness of the open source community and the amount of sort of like complementary connectors that you can use in your project that are fueled by so many people using this with really popular tools and not popular tools. So I think that makes it sort of particularly reliable and useful for people and extensible. But otherwise, I mean, it depends on your use case. Like Airflow isn't for everyone. And if you're already running in Azure or you're already running in AWS and you just need to kick off really simple jobs, like admittedly, sometimes cron jobs or things like that just do the trick. But if you're really looking to create a more complex sort of like orchestration landscape, I think Airflow is built primarily for that. And then of course, Astronomer brings more value to that. But yeah, I'd say those are sort of the main value adds.
So I did want to just interrupt for 1 second. I forgot, and this kind of shout out to everyone that stayed for the presentation. But Astronomer, the company here, actually gave us a free code to actually take that course that Paola was talking about, the the Airflow certification course. So I'm going to drop that code in the Slack channel tomorrow, probably, and you can use that code and take the course for free. Both courses that they're offering on the Astronomer Academy website. So I'll drop the details there, but it's pretty cool. You can get certified, and these guys are the leading authority in it. So it'll be nice to add to your resume.
Yeah. I don't know if Cole's on here, but it's great that we're doing that. So definitely encourage folks to not have to pay $150 to take that course.
Yeah, it was very cool.
So,
Just drop the invite to the Slack channel in the chat. So if anybody wants to join our Slack, you can join from there.
cool.
Any closing questions?
So I have a quick question. So in terms of like the Apache Airflow that you mentioned, what are some other things that you can learn around that sector? Just trying to get a better sense. What
do you mean?
Like this wasn't a prepared question, so
No,
it's on the
okay.
spot. I guess because like I'm a student and I'm trying to get more in the infrastructure side, and I'm trying to figure out what are the best ways to kind of like dive into there. So any tips?
Mm-hmm. Yeah. So for Airflow wise, like I said, honestly, something like our CLI is super easy and literally takes 5 minutes. I think something that helped me understand how Airflow works under the hood and how you deploy a project onto some infrastructure, like doing a Docker Compose tutorial was sort of helpful from what are the principles that are used here and what are the tools you can connect. But I think there's definitely a vast wealth of resources. I'm curious, honestly, from other folks in the group, what they would say as actual data engineers who have gone through that phase. So Sam, Brandon, I don't know if you two in particular have any pieces of advice there.
Sorry,
I'll let Sam take it because he did a panel on this exact
Oh,
topic.
there it is. What was the question? I think the question was if you're actually Himinesh, I think that's you who asked. Do you want to re-ask your question?
Yeah. So the question was in terms of if you're trying to go more on the infrastructure side, what are some things also, I mean, including the Apache Airflow, but other things that can make you stand out? What are some other way, I've played around with Wireshark and Tripwire and all that, but outside of that, I'm not as very familiar. And even role wise, what would you be aiming? I know this is not a question to be asking on this type of a call.
So I'm not familiar with Tripwire or the other thing you mentioned, but is your question what will make you stand out, be attractive to an employer or something like that? That's what you mean, right?
Yeah.
Okay. About infrastructure specifically?
Mm-hmm. Yep.
Well, I guess it depends on what you want to do. If you want to, AWS is a whole, well, I work with Amazon stuff specifically. It's been a while since I played with Azure, but they've got a whole bunch of videos and stuff on EC2, Lambda. It's kind of hard to answer the question because it's pretty broad, and I guarantee you, if you ask like 20 people in Arvade individually, you're going to get a different answer from each one. But
okay.
Yeah, I guess trying to narrow down what specific services or roles you're interested in, data engineer, architect, data scientist, or something like that, and then looking at some of the tools they use, and then kind of starting from there.
Okay, because then from one of the professors who's more on that side, he kind of told us to work more on the AWS key management console and like I think it was like the Amazon SQL Server and all of those other tools. But when I went like researching on roles wise, I wasn't sure if I should be looking for like the network engineer type of roles or like ones of somewhere around that. I don't know if you were supposed to be looking for roles, would it be dependent on like the types of skill sets or would it be more dependent on like just what would you be willing to learn?
Yeah, I think it's a little bit of both. I mean, like, data engineer, no one here went to like school to be a data engineer, I don't think. But we all ended up in these roles probably just through a handful of different projects that got us like the experience that qualifies us to be data engineers, I guess. And like some of us here aren't even data engineers. Like Brandon's like an ML engineer, which isn't exactly the same thing. And David is a wizard of all sorts of skills and stuff. And so he's got more skills and that qualifies him to be a data engineer. I don't know, man. I guess it would be more of if you don't have the experience, maybe look into like, starting some courses or looking into some videos or, hang around here for a little while, the meetup and stuff and see if you like it. And hopefully that, gives you a little bit of insight because it's hard to get some hands-on experience as an engineer already,
Yeah, I totally get that. Actually, the one who recommended me to go over here was one of the professors at VCU who just said this might be a good way to start. So yeah.
Was his name Peter Aiken by any chance?
Yep.
Was that Noah? Yeah.
Peter sent me too.
Yes.
Yes.
So yeah, he's the one who sent me over here saying that you should probably go to one of these meetups. I was like, okay.
Yeah, I think this is a good place to hang around. I mean, if you're still a student, you can at least get a little exposure and get to know some folks. Of course, it's not as easy to like network and stuff because we're all remote and we can chat for like, if you can't just ask a one-on-one question, you're going to be put on blast and everyone's going to hear it. But that's okay. I think that.
Hey Sam, why don't we wrap up the actual official meeting, and then if you guys want to hang out and chat, talk about jobs or whatever, like that, we can hang out for a while. I can hang out for a while. So like, why don't we let Paola kind of finish up? I mean, I think let her go if she wants to go, and then yeah.
Let me go. No, I'm kidding.
if there's any other questions for her, like we can talk about other stuff afterwards.
Mm-hmm.
Yeah, I think there's some questions about the slides. So Brandon, I'll take your lead. I mean, I can literally just drop the link in this Zoom chat, but also I don't know if you want to send a follow-up email.
Yeah, if you just want to email them to me, we usually post the slides along with the YouTube link as well. Okay. David takes care of that. So.
Okay.
Thanks so much. This is really good. So
yeah,
appreciate you coming and taking the time to talk to us.
Yeah, this is super fun. I actually don't do these super often, so it's fun to. They're fun to do. So happy to do another one. Or there's so many folks on our team who are so smart and Airflow Astronomer or otherwise. So Brennan, happy to keep in touch. And you have my email, so if anyone wants to follow up, chat Airflow, more than happy to do that. But yeah, enjoy the rest of your weeks and hope everyone's staying healthy and good. And I think that's all I got.
Thank you, Paola.
All right. Bye, all.
Thank you.
If anybody does want to hang out for a little while, we can do that.
Yeah, I got a few minutes if you want to hang back, Himinesh.
Hey, Brandon and David, thank you for this was a good session. I think Paul offered to have another session, I think a more detailed or a little bit deep dive on the same topic.